Dear students, today we'll learn the equations of motion for vertically projected bodies. So already you know the equations: v equal to u plus at, s equal to ut plus half at square, v square minus u square equal to 2as, sn equal to u plus a by 2 into 2n minus 1. So you know initial, final, acceleration, time and displacement given the equations, right? So that means a body is projected upward from the ground is known as vertically projected bodies. That means against gravity here. Against gravity, the body projected upward. Projected upward with uniform acceleration. So in case of freely falling bodies also acceleration uniform. In vertically projected bodies, see, in case of freely falling bodies, initial velocity 0. For vertically projected bodies, let it be this is a ground, so without velocity the body won't move, so initial velocity required this is, so initial velocity, let it be u meter per second. It's going against gravity. So what will happen? The velocity will be decreases, finally comes to the rest. So this is the maximum height, the consideration. At the maximum height, final velocity will be 0. After reaching the final velocity 0, then body will be again come back to the ground here. That means initial velocity required u only, final velocity will be 0 at maximum height. This is case maximum height, and s equal to h, and time taken t is equal to t here, and displacement s equal to h here. So what do you mean by the first equation of motion here? So you know first equation of motion, that is v equal to u plus at here. So final velocity what here? Final velocity will be 0. Initial velocity u will be there, and one more thing, while body moving upward against gravity, a is equal to consider as a minus g. See, for free fall we will take it as a is equal to plus g. This will be a equal to minus g. So we a place you write minus g into t here. So then u is equal to gt. So this is the first equation of motion. So from this first equation of motion only we can take it is the time t is equal to u by g. So time of ascent. So what do you mean by the time of ascent? That means time taken by the body to reach maximum height is known as time of ascent. Okay, so in this time of ascent, t is equal to u by g. So time is directly proportional to the initial velocity here. So when velocity increases, then time also should be increases while projected velocity, initial velocity. So this is the time of ascent, time taken the body to reach the maximum height. Next one is second equation of motion. You know that s equal to ut plus half at square. So s nothing but a h, that means body projected upward, right? This is s equal to h ut plus half a nothing but a minus g into t square. So h equal to ut minus half gt square. So this is the second equation of motion. So that means here final velocity 0, a value should be minus g. It has an initial velocity there, that is u, and time taken is t here. So this is the second equation of motion. Here minus nothing but a acceleration due to gravity against that. So third equation of motion, what is that? V square minus u square equal to 2as. So what is the v square minus v square is 0 at max height, u square 2 into minus g s nothing but a h max, maximum height. So that means minus u square equal to minus 2g h max. So minus minus cancel, u square equal to 2g h max. So therefore maximum height equal to u square by 2g here. So this is the maximum height formula. That means body projected upward with initial velocity at final velocity will be 0. This is the, we'll consider as a h max, maximum height. So for maximum height formula to finding u square by 2g, very important formula. See, at a maximum height here acceleration will be won't 0. See, velocity will be 0 but acceleration won't be 0 because acceleration is the acceleration due to gravity. That means velocity the 0, acceleration will be won't be 0. But in the normal cases, body moving along the surface, velocity 0 means acceleration 0. But vertically projected bodies, acceleration will be not equal to 0, that is acceleration due to gravity. So then fourth equation of motion, Sn equal to u plus a by 2 into 2n minus 1. So hn equal to u minus g by 2 into 2n minus 1. So this is the fourth equation of motion, displacement or distance covered by the nth second here. This is the formula. So that means, see, the body projected upward, that is time of ascent u by g. When it reaches the maximum height is 0. Okay, while it is moved, when it reaches maximum height, final velocity 0, what will happen? The body will come back to the ground. That has here reverse initial velocity 0, and here the velocity, how much you are projecting, the same velocity it will be here while moving downward at the ground. So that means this is also time of descent, that is u by g. So that means the total time of flight. So the time of flight nothing but a time of ascent plus time of descent. So time of flight should be u by g, time of descent also u by g. So therefore time of flight formula, so 2u by g. So that means time of ascent and time of descent is same. Time of flight means the body, how much time taken the body remains in the air, that is total time. So that is 2u by g formula, time of flight formula. So time of ascent is same, time of descent also same. That means for vertically projected body at the same level, velocity should be same. Suppose here 40 meter per second upward is there, here downward also will be 40 meter per second. The same level, here the velocity will be suppose 60 meter per second, here downward also will be 60 meter per second in opposite direction. So here final velocity 0 while upward, while downward its initial velocity also 0. At touch the, how much you are projecting the velocity, the same velocity it will reach. So that means what we learn the equations in the vertically projected, first one is equal to u is equal to gt. What is u? Projected velocity. Second one h equal to ut minus half gt square. Third one is h max, maximum height, u square by 2g formula. And fourth equation of motion, hn equal to u minus g by 2 into 2n minus 1. So these are the equations of motion while moving upwards. So you can apply these equations according to the given question, right? Hope you understand. Thank you.